Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have an easy today. It's called divisible and non-divisible sums difference. So we're given two ints, n and m, and both of them are only 1,000 big at most. So so let's see what it wants. So define two integers as follows. So num1, the sum of all integers in the range 1 to n, are inclusive that are not divisible by m, and num2 would be the sum of all integers in the range 1 to n that are divisible by m. And we want to return the integer num1 minus num2. Okay, that doesn't seem too hard. But let's look at an example first. So if n is 10, m is 3. So I think we want to pick out like 3, 6, and 9 because those are divisible by 3. Yeah, so there it is. So integers in the range that are divisible by 3 are 3, 6, and 9. So num2 is the sum of those integers. Well, it will be equal to 18. Yeah, so I can think of both like the O1 solution and the ON solution. But maybe let's just code up the ON solution because we can here. Like it's only 1,000. So we have like let's just call it like x and y, and then at the end we want to return x minus y, right? So what we want to do is we want to do for I in range. So we want to loop through all the numbers from 1 to n. So so if I is divisible by m, we want to add that to y, otherwise we will add that to x. So I think that should work. Yeah, just a very short. Oh, what did I do wrong? Minus 19 is equal to 0. I made that mistake a lot of times. Yep. Now it should work. Yeah, there we go. Maybe I can talk about the we have time, so I can talk about the O1 solution as well. So so let's comment that out. So for the O1 solution, we need to know something called the arithmetic series. So basically what you can do is so like let's look at example 1, right? So what we have done right now is we have just get the numbers divisible by 3 out, right? And then like we keep the ones that are not on top. And that'll work, right? Because like we just need to find a difference between that. But a quicker way is actually, well, if we know the sum from 1 to let's say if we know the sum from 1 to 10 quickly, so like this would be you add all of them, and then you actually minus, so you get rid of all the numbers divisible by 3, so that'll be like, and then like all the way to 9. So this thing is going to give you the first sequence, right? And if you subtract from the second thing again, so that would be like all the numbers divisible by 3, you get the exact same thing as what we have done. And so what is this equal to? Well, it is equal to the arithmetic sum from 1 to 10. So if we use the arithmetic series, which is so the first item plus the last item, and then you want to multiply by the number of items in that series divided by 2. So that will give you an answer, right? So for here, so it'll be 1 plus 10, and then multiply by 10 divided by 2. And then we have 2 times. Well, remember these series are the same, right? So we start with 3, and then we add 9. And how many items are there? Well, there are only 3. And then we can divide that by 2. And that will give you the answer as well. So that would be a constant. So this is the constant time way of doing it. And yeah, we can code this up as well. So like what we need to do is well, like the thing that takes a bit of like thinking is how to find the last element that is divisible by m. But it's not too hard because we can use modulo to find that. So yeah. So we need to find the largest. Yeah, just call it like L or something. So we need to find the largest number. And what we will do is we'll get the largest number modulo m. So that's going to give us the remainder. And if we just do the largest number minus the remainder, we are going to get, well, like the first number, well, the biggest number with zero remainder, which is the number that's divisible by m. The largest number that's divisible by m, right? And then what we need to do now is so we just need to return 1 plus n times n divided by 2. So that gives us the first series, like so like from like adding from 1 all the way to n. And then we need to minus 2 times well the starting number that is yeah, so the starting number of the divisible series, so like the nums2 series is going to be m, right? So for example, is m is 3. Well, the first number is going to be 3. So we have that, and then plus l. And then we need to find out how many numbers are actually in here. So yeah, so how do we do that? That's another thing we have to like think about. So I think it would be the largest number divided by m. Yes, because so the largest number divided by m will give you, like for example, like 369 here. 9 divided by 3 will give you 3, which it makes sense that it gives you the number there. So we have so L divided by m, and then we need to divide that by 2. So yeah, and another thing we have to think of is what happens if m is actually larger than n? Like, what do we do in that case? So I think I actually think we have to do a subcase for this. Yeah. Yeah, okay. I got an idea. So if m is greater than n, well, we just return the arithmetic sum because we won't have any elements that's divisible. So what happens if n is equal to m in if they are equal, so like n mod m is just going to be 0. So that's going to be n, right? So that's the last element. But our first element is also, yeah, so we don't actually have this term here if they are equal. So I think like if they are equal, we have to do another case here. So return 1 plus n minus 1 times n minus 1. So only the last element is going to fit in the, it's going to be in the like divisible thing. So like that's why we just don't count it. We have some bugs to fix. Seems like should be that way. Okay, let's see if we have any bugs. Oh, we do. Oh, okay. Expected is -1. So if they are equal, yeah, of course. Yeah, I need to I have to subtract the largest element here. So like what I've done is I've just calculated nums1 here, but I forgot to minus nums2. So I think now it should work. Yeah. So that would be the constant solution using arithmetic series. And yeah, I think like to think about how to like do this question quickly, the really only thing you have to do is like know arithmetic series. But yeah, and also like you have the different cases. The slower way is just extremely simple. It's just like implementing what the spec wants. So yeah, thanks for watching, and I'll see you tomorrow. Bye.